In this video, we're going to look at writing nuclear reactions or nuclear equations, knowing what sort of decay the element or isotope undergoes. So we have gold 201, uranium 232, and einsteinium 252. So I'm going to write all three of those down right now. So gold is Au, and we have gold 201, so I'm going to put that up high like this. Then I have uranium 232. So these numbers that I'm writing down are the atomic mass of the isotopes. So we have einsteinium 252. Alright, so then I have to go back to the periodic table and I have to get the other information that I need. So here's gold. You can see that this would round off to 197, so that would be like the stable kind of gold. And we have gold 201, which means it's an isotope, so an unstable or radioactive isotope of gold. And gold has an atomic mass of 79. So I'm going to put 79 down below here. Uranium is number 92. And einsteinium is number 99. Alright, so these things are going to undergo some sort of radioactive decay. And so it tells us that gold emits a beta particle. So you have to know what a beta particle is. A beta particle is an electron which has a mass of 0 and a charge of -1. Nuclear reactions are based on conservation of mass and conservation of charge. So we need to know that. Uranium undergoes alpha decay. So an alpha particle is a helium nuclide or nucleus, so it's a helium 4-2. And einsteinium undergoes gamma decay, and gamma is a ray or a wave, so it just has a symbol. So the next question is, what does it turn into? We are applying conservation of mass and conservation of charge. So in terms of conservation of mass, 0 plus something has to be 201. And something minus 1 needs to be 79, or -1 plus something needs to be 79, so this is going to be an 80. So the question is, what is 80-201? So I have to look at the 80, and the 80 is mercury. 201 looks like a stable form of mercury here, so Hg. This is the nuclear reaction, writing the whole thing down. All right, the next one is uranium 232, conservation of mass. So 4 plus something has to be 232, so that's going to be, what, 228? 228, I think, and that would be 90 plus 2 is 92, and that's conservation of charge. Those are like the positive protons. So what is 90? 90 is thorium. And I can also see here that thorium has a mass of 232, so I have a different isotope, so again it's perfectly or 100% radioactive. Alright, and then the gamma decay, because this is a wave, it has no mass and it has no charge, so I just don't write those, but it means that it does not turn into a different element. So it stays the same, but it actually just releases some radioactive wave as in its decay process. Alright, so those are the answers for number 3.